Hello. Now for finite difference representation. So what you need here is this. Follow this graph, this 4 cardinal points. So we have x coordinate and we have y coordinate. This side is x, positive x coordinate, and negative x coordinate, and from here upward is positive y coordinate, and from here downward is negative y coordinate, which means for the positive x coordinate, it means s is increasing towards this positive side, will be decreasing towards this negative side. This one increasing upward and this one decreasing downward. So that's why you are seeing this s comma y. So increasing here will be what? X plus delta s. This delta s is a small increment there, so that's why it's x plus delta, because it's positive increment. So there's no increment in y, that's why you're seeing only y here. So now for this side, s is decreasing, this is small decrement here, so that's why you see x minus delta x. Y, there's nothing happens to y. So from the y coordinate here, y axis like this, only y will be increasing because s will just still at 1 here, like this x comma, the only increment here is y. That's why you are seeing y plus delta y. So note this down like this. So after that, you need to know 4 equations that you need to know here is this. There are this equation 1, equation 2, equation 3, and equation 4. So how to derive all these equations is very simple. Okay, now let's start here. See, subscript, all this one is subscript, they are not on the same line. It's subscript to t. This bracket x plus delta x comma y subscript, this is t subscript this. So now t subscript x plus delta x comma y, it means the increment is towards x, positive x direction. So anything that you want to do here will be towards this positive x direction. So you don't need anything in your negative side or your y direction. The only increment is this. So how to start now? Anything that you want to start, all these equations, like you need to start this equation, you start them from 0, from power 0, power 1, power 2, power 3, so that you will not make any mistake. So now let's start for this one now. The t subscript s comma y that you are seeing, it's not just only t subscript s comma y. Start from like this. This one is like this delta power 0 t comma x t bracket subscript s comma y divided by delta x raised to power 0. And you know delta raised to power 0 is 1. It remains t subscript s comma y. Delta s raised to power 0 is also 1. So you know the remaining thing here is what? T x comma y. For this one, we are working for this one now. I'm just using this one to explain the way this is just only t subscript s comma y. Because you might be thinking, why is this one is not like this? So it's the same thing. So multiply by delta x. For this one, it will be, because it's under what? Power 0 here. This one will now be delta x raised to power 0 over 0 factorial for this one. And 0 factorial is 1. Delta x raised to power 0 is also 1. 1 over 1. This one is also 1. This one is also 1 for this side. Everything is 1, 1, 1, 1, 1. The remaining thing here is what? T subscript s comma y. So let me quickly show you. This. So for the power 0, because the first one is power 0. So delta raised to power 0 t subscript s comma y divided over delta x raised to power 0 delta x raised to power 0 over 0 factorial. Everything here is, this one is 1, this one is also 1, 1 over 1, 1, t subscript s comma y multiplied by, this one is also 1, so 0 factorial is also 1, 1 over 1, the remaining thing is what? T subscript s comma y. That's why it is. Come back here. Now, so I think you know that now. So plus, you know we are in positive direction, right? And don't make any mistake. So the second increment now is what? From 0, it will now increase to 1, to power 1. So delta power 1 t subscript s comma y over delta s raised to power 1 the s raised to power 1 multiplied by delta x raised to power 1 over 1 factorial. This is the first increment. Another increment, power 2, d raised square t subscript s comma y over the s square multiplied by delta x. You know it's in the second phase now. Delta x raised to power 2 over 2 factorial. So what you need to know is that anything that is here must be here, and also here, and here. You know everything is the same. 2, 2, 2, 2. So if you don't have 2, 2, 2 here, there's a mistake there. So you need to rewrite the equation. So the plus the third one, d raised to power 3 t subscript s comma y over the s cube multiplied by delta x raised to power 3, the increment also raised to power 3 divided by 3 factorial, plus and so on like that. That's your equation 1 for the increment towards x positive s direction. So now you don't need to waste time again for decrement towards x towards negative x direction like this. For the increment is what? Delta x minus delta x minus delta x comma y, because it's only x that is decreasing here towards this. So nothing happens to y because this is not the y direction. This is not y axis. Y don't have any say here. So y will just keep quiet. So that's why you see y keep quiet here like this. So the next thing is what? The way you do this, so yeah, follow that trend. T the subscript s comma y minus, you know it's decreasing towards x. So minus dt s comma y over the x d delta x over 1 factorial, plus second one is there. So it's like this. So second one is like this, delta d square dt and so on like that. Subscript s comma y over the s square multiplied by delta x raised to power 2. You know this one is minus. So when you get to this side, it's like you are multiplying this also with minus 1. But the square will now change that minus 1 to plus. That's why you see this plus there. It's like you are saying, because of the negative direction that this is going, this one multiplied by minus 1, you get minus, multiplied by minus 1 square, you know, minus 1 raised to power 0 here. You know I say everything here will be raised to power 0, everything in the second direction we also raise to power 1, everything here we raise to power 2, power 3, everything there. It's only t subscript s comma y that will not be changing. So now the next thing is what? Now let's use minus the negative sign here. Like minus 1 raised to power 0 is also 1. So it will not have any effect here. Here, minus 1 raised to power 1, because this is 1 power 1 region, right? You have what? You have minus 1 there. So minus 1 square return to positive. That's why you are saying positive for this side. Minus 1 raised to power 3 here, negative. That's why you're saying negative. Another one, minus 1 raised to power 4, positive. Raised to power 5, negative. It will now be minus plus, minus plus, minus plus, like that. That's equation 2. The equation 3 now. The third equation, we've done with this x axis, the one increment towards positive s and increment towards negative s. So we are done with that now. So the next one is what? Moving towards y axis here. So first move towards positive y axis, like increment towards y. So on this y axis, s will what? Keep quiet. X will not say anything. So it's only y that will be increasing. X will just be looking like, oh, wow, confirm. Keep going. So that's what you'll be seeing there. So now, t x comma y for this third one, x comma y plus delta y. It means it's only positive y that is increasing. Follow the same trend. First one will be power 0, d raised to power 0, t subscript xy over dy. You know the other one is dx because it's only x that is increasing. Now y is now increasing. Now the increment is on y now. So now say divided by dy raised to power 0 for this first one. You know you need to start from power 0. You can even write it out if you don't want to make any mistake. You can write it out so to avoid error. So now all over ty raised to power 0, and d raised to power 0 here is 1, and dy raised to power 0 here is also 1. So you get, so multiply by delta y raised to power 0 here also is also 1. Divided by 0 factorial here is also 1. That's why you are not seeing all those things here. You are not seeing them here. So it remains only t x subscript s comma y only. Others are 1s. So plus the t now, this is the first derivative now, power 1. So the t d raised to power 1 t subscript s comma y all over dy raised to power 1 delta y raised to power 1 over 1 factorial. You see the 1 here, 1 here, 1 here, 1 also here. Everything must be the same. If you don't want to make any mistake, if you don't have any, if you have anyone that is different, there's a mistake there in the equation, because this is the basic now. This is sort of the equation. So we are trying to derive all those equations before you now use them for the first order forward difference, first order backward difference, first central difference, and also second order, like that. So that's why you need to derive this formula. You need to understand the formula very well, the equations very well. So now the next thing, second one also, power 2 and power 3, go on like that. You can go to power 4, 5 if you like. So the fourth equation is t subscript s comma y minus delta y. Y is now decreasing towards negative, y axis here is decreasing towards negative. So you follow this, the same trend, t subscript s comma y minus dt sy dy. This one is power 1, power 1, power 1, power 1, and this one is d square t s subscript s comma y dy square, because it's power 2, everything will be power 2, and the 2 factorial also will be 2. And you don't forget the reason why you're having minus and you have plus, because this one is in positive direction. This one that is in negative direction, you multiply everything by minus 1, and you follow the trend of when you are at the 0 power, you follow the trend, minus 1 raised to power 0 also. You are at the power 1, minus 1 raised to power 1, that's why you're having minus here. Because minus 1 raised to power 1 is minus 1. Minus the second power, minus 1 raised to power 2 also. You will be what? You will be 1. That's you're having positive here. So the third power, minus 1 raised to power 1 is minus 1. Fourth one, minus 1 raised to power 4 will be positive. That's why you're having positive, negative, positive, negative, positive, negative. So it depends on the power. The power is the one affecting it. So don't forget that when you are at this negative region, like this, negative x and negative y, you need to do what? Make sure you multiply it by minus 1 each. So that's all for the equations you need for the finite difference representation. So, and make sure you note this also. Delta x, or this ds, is small increment. So this one like this is partial differential, and this one is full differential. So note that. So don't just be writing d for everything. So now let's move. The next one is what? First order forward difference. So first order forward difference. Now, if you want to do first order forward difference, you will first check one now. You know, forward difference. First order is what? First order forward difference. You must go towards the forward. You are going forward and you are still positive. If you are walking now, let's assume you are walking somewhere. You're now walking through your back. You know, you can collide, you can fall at any time, because you are walking negatively. So let's put it like that you are walking negatively. So it means you are not forward. When you are moving forward, you are walking positively. So that means that you need to walk towards this positive x direction and positive y direction. Positive x direction and positive y direction will make your first order forward difference. So it means you have to get the equation that is for the x increment towards s, positive s, and the equation towards positive y. That's the equation that you will use for your first order forward difference. So now let's move on like this. So from equation 1 now, you know equation 1 is this equation 1. And I said equation 1 is for increment towards x, positive x. So that's what you need here. From equation 1, here. From equation 1. So the equation 1 now, you just bring this t of s, because it's the one that, as you know, this one don't have any d data here, D or D1, D2, and so on like that. This one don't have DDS. It's not for this. It's only T. That's why you are bringing it out. So that you have only those that are with D or D of S, D or D square of DS square, and so on like that. So just bring this one outside like this. It's not on, I said in the former videos, previous videos, that anytime you are moving over this equals to, it's like you are crossing boundary now. You are moving from one country to another. You can't just be, I'm a Nigerian, you're now reach US, and I'll be Ghana, you now say I'm a Nigerian. You have to have what follow their own constitution there. So now this T subscript S comma Y come to this side. So that's why you are seeing it here like this. So the remaining one is what? D dx T subscript S comma Y delta X over 1 factorial plus D square, and so on for the second, for the third, and so on. So the next step here is what? There's no change. You don't change anything from this equation. The only thing you change is just with that we move this one to this side. That's the only thing. Don't let it affect you. So the next step is what? Divide both sides by delta X, the small increment there. You divide both sides. This side by delta S, this side by delta S. That's what you're seeing here. This side over delta X, and everything here now over delta S. Just do it one by one. For this first one here, everything DDS T subscript S comma Y delta X divided by delta X. You know it's 1 factorial, so you don't need to write 1 factorial is also 1. Plus for the second one, D square ds of T comma Y delta X square, that is there already here, divided by delta S. The 2 factorial is there, so it's not going anywhere. So and one data will cancel this second data here. It remains 1 data X here. The third one also, data here will cancel this. It remains data X square. So and so on like that. So let's proceed. Cancel all those ones out. The remaining ones is like this. So everything here, T X comma S plus T subscript S plus data X comma Y minus T subscript S comma Y, everything all over delta X equals to D T subscript S comma Y over the X plus, that's the only thing remains here. Delta S cancel delta X. The remaining here is what? This. Plus delta S cancel 1 here. It remains 1 delta X over 2 factorial. The third one here, so it remains delta S square over 3 factorial there. So now you know that this delta X is small increment. So delta X, since this delta X is small increment, yes, it means delta X square here, the second one here, and delta X cube is even smaller than the delta X. So note that. So now if that is okay, if that is right, so it means everything here divided by delta X equals to D T subscript X comma Y over dx plus everything here return to 0 because they are very, very small. So you can't predict that this is the actual amount, this is your actual number of it. So that's why using it represent everything by 0. So the remaining thing is what? D T subscript S comma Y over the X equals to everything here like this. That's for the first order forward difference along x-axis. So don't make any mistake, along x-axis. And I said before you can complete first order forward difference, you must go along positive x-axis and positive y-axis. You now add everything together equal to 0. That's your first order forward difference equation. So this is not where we are going to use. So now let's move on. Now the next thing is what? Next thing here is that you do double subscript notation. That's the next thing we need to do. To get double subscript notation, come back to this side. This. Everything, anywhere that you see X, you put I. Anywhere that you see J, Anywhere that you see y, you put j for double subscript notation. So, and anywhere that you see increment like delta x, you represent it by 1, that is increase by 1. So if it is negative side, -1, positive side, positive increment is what? Plus, increment is +1, decrement is -1, for everything like that. So now let's go for the double subscript notation now. And also, if for double subscript notation now, if you are on the x-axis, your delta x that you used it to divide both sides the other time, we thought we equal to what? H, and delta y for y direction or y axis we equal to k. So now let's go on like that. We have d t x comma y over dx in the previous page equals to t plus 1, t subscript x plus 1 comma y minus t subscript x comma y all over delta x. That's what we are in the previous page. So now say, following this double subscript notation now and changing of delta x to h, so the equation we have dt I comma j instead of x comma y divided by dx equals to t instead of x plus 1 is now to I plus 1 comma j, because you are in the x increment. If it is y increment, this j will be increasing, x will just be I, and the j will now be j plus 1 if it is on y direction. If it is in y direction, so minus t subscript x comma y is now I comma j divided by delta x is now h. So that's our first order forward difference in x direction. So from equation 3 now, our third equation is what? The third equation is for positive y. Y is increasing now, the positive. You can check it. The third equation, you now bring out the first t subscript x comma y, bring it out like the way we did for the x increment. So we did it for this, and note that the denominator will be dy, and the delta is not delta x again, it's delta y. That's the only thing that will be changing there. Follow the same trend like this, that we did for the x, and divide both sides by delta y, not delta x, and follow it like that. Divide both sides, cancel delta cancel square, cancel this cube, remain square. So this one also cancel. We follow the same trend. It's the same thing. The only thing that's changing there is just that delta y is one changing there, and the y is changing also. So after that, if delta y is small increment like we did for delta x, then delta y square is also smaller. So now the same thing, we write it like this. Because they are small increment, everything turns to 0. It remains only d t subscript x comma y over dy. Follow this also, rewrite, move this one to this side and this to this side. So using double subscript notation that the other time we did, change x to I and change y to j, and the delta x plus s y plus delta y will now change. That delta y will now change to 1. It will now be y, it will be j plus 1 instead of y plus delta y here. It will be j plus 1. So now this is the result. Instead of I, x here is now I, y here is now j dy. I here, x here is now I, and your y plus delta x is now j plus 1 minus t subscript x comma y is now t subscript I comma j over the delta y is k. For the double subscript notation, we change to delta y to k. So that's the first order forward difference along y axis. So therefore now you now say for the forward difference, first order forward difference now, for the whole equation, it now be dt over the x. That means forward difference along s axis, s direction, plus dt over the y, forward difference along y direction. Here, this one you get equals to 0. It means you plus this one this one, this is for the x direction, plus the one you get for the y direction here. Everything equals to 0. That's what you are seeing here. And this one is now the first order forward difference. So that's all. Thanks for listening. Thanks for watching. Wish you best of luck.